First subject is discrete structure and optimization of the mathematics, counting, group theory, graph theory, and the subject. Then computer system architecture, microprocessor and the programming language, programming language, computer graphics. Object oriented programming and programming and database management system. DB is an important subject. DBM is very important subject. System software and OS. System software OS is important. Syllabus share. Software engineering theory ആണ് വരുന്നത്. അത് നിങ്ങളെ പഠിച്ചാലായിരിക്കും നിങ്ങളത് ബൈ ഹാർട്ട് കുറെ കാര്യങ്ങൾ പഠിച്ചാൽ മാത്രമേ അതിനെ ആൻസർ ചെയ്യൂ. പിന്നെ ഡാറ്റ സ്ട്രക്ചേഴ്സ് ആൻഡ് അൽഗോരിതം അത് നിങ്ങൾക്ക് അറിയാം. ആ സമയത്ത് നമുക്ക് ഡിസ്കസ് ചെയ്യാം. ഡിസ്കസ് ചെയ്യാം എന്താണ് ഡാറ്റ സ്ട്രക്ചേഴ്സ് അൽഗോരിതം എന്ന് പറയുന്നത്. ഞാൻ മെയിൻലി കോൺസെൻട്രേറ്റ് ചെയ്യുന്നത് നെറ്റിലെ ഏറ്റവും ടഫസ്റ്റ് സബ്ജക്ട് എന്ന് പറയുന്നത് അതിപ്പോൾ ഏത് കോഴ്സ് എടുക്കുകയാണെങ്കിലും MSc ആണെങ്കിലും MSc ആണെങ്കിലും BTech ആണെങ്കിലും ഏത് കോഴ്സ് എടുക്കുകയാണെങ്കിലും ഗേറ്റ് ക്വസ്റ്റ്യൻസ് ആണെങ്കിലും നെറ്റ് ക്വസ്റ്റ്യൻസ് ആണെങ്കിലും ഏതിലും ഏറ്റവും കൂടുതൽ ക്വസ്റ്റ്യൻസ് ആയിട്ട് വരുന്ന ഒരു സബ്ജക്റ്റ് ആണ്. നിങ്ങൾക്ക് തന്നെ അറിയാം കുറച്ച് ടഫ് ആയിട്ടുള്ള ഒരു സബ്ജക്റ്റ് ആണ് തിയറി കമ്പ്യൂട്ടേഷൻ ആൻഡ് കമ്പൈലേഴ്സ് എന്ന് പറഞ്ഞിട്ട്. ഈ തിയറി കമ്പ്യൂട്ടേഷൻ ആൻഡ് കമ്പൈലേഴ്സ് ആണ് ഞാൻ കുറെ ആയിട്ട് ഡീൽ ചെയ്യുന്നത്. അപ്പോൾ ഇതില് മെയിൻ ആയിട്ടുള്ള അബൌട്ട് ദി സബ്ജക്ട്സ് അല്ലെ. വി ആർ ടോക്കിംഗ് ഡിഫറെന്റ് കമ്പ്യൂട്ടേഷൻസ് ആൻഡ് ഡിഫറെന്റ് പ്രോസസിംഗ് ഓഫ് കമ്പ്യൂട്ടർ, ഡിഫറെന്റ് ഗ്രാമേഴ്സ്, different language models, okay, then different types of machines, for example meta, NFA, DFA, Turing machine, അങ്ങനത്തെ കാര്യങ്ങളൊക്കെയാണ് തിയറി കമ്പ്യൂട്ടേഷനിൽ വരുന്നത്. ആ തിയറി കമ്പ്യൂട്ടേഷൻ റിലേറ്റഡ് ആയിട്ടുള്ള ഒരു സബ്ജക്റ്റും കൂടിയാണ് കമ്പൈലർ ഡിസൈൻ. ബിക്കോസ് വി ആർ യൂസിംഗ് മോസ്റ്റ് ഓഫ് ദ കൺസെപ്റ്റ് ദാറ്റ് ഈസ് കമ്മിങ് അണ്ടർ ദ തിയറി കമ്പ്യൂട്ടേഷൻ ഇൻ കമ്പൈലേഴ്സ് ഓൾസോ. സോ ദീസ് ടു സബ്ജക്ട്സ് ആർ ഇന്റർ റിലേറ്റഡ്. ഓക്കെ, നമുക്ക് ഈ രണ്ട് സബ്ജക്റ്റിൽ നിന്ന് തന്നെ ഈ രണ്ട് സബ്ജക്റ്റിലെ ഓൾമോസ്റ്റ് എല്ലാ ക്വസ്റ്റ്യൻസും ഒക്കെ നിങ്ങൾക്ക് സോൾവ് ചെയ്യാൻ പറ്റിക്കഴിഞ്ഞാൽ ഏത് എക്സാമുകളും ഏത് കോമ്പറ്റേറ്റീവ് എക്സാം ആയാലും അത് ഗേറ്റ് ആയാലും നെറ്റ് ആയാലും അത് ഏത് ഗവൺമെന്റ് പബ്ലിക് സെക്ടർ എക്സാംസ് ആയാലും ക്വസ്റ്റ്യൻസ് കണ്ടുവരുന്ന ഒരു ഏരിയയാണ് തിയറി കമ്പ്യൂട്ടേഷൻ കമ്പൈലർ. ഓക്കെ, അതാണ് എപ്പോഴും ഒരു ബാരിയർ ആയിട്ട് നിൽക്കുന്ന സബ്ജക്റ്റ് ആണ് ഈ ഒരു തിയറി കമ്പ്യൂട്ടേഷൻ കമ്പൈലർ എന്ന് പറയുന്നത്. കാരണം ഇതിൽ നിന്ന് വെച്ചാൽ നത്തിങ് ക്യാൻ ബി ബൈ ഹാർട്ടഡ്. അതാണ് ഈ സബ്ജക്റ്റിന്റെ ഒരു ഇമ്പോർട്ടൻറ്റ്. നമുക്ക് ഒന്ന് ബൈ ഹാർട്ട് ചെയ്തിട്ട് ഇതിൽ എഴുതാൻ പറ്റില്ല. ഇതിലെല്ലാം നമ്മുടെ ആ കോൺസെപ്റ്റ് കറക്റ്റ് ആയിട്ട് മനസ്സിലാക്കി അതിനെ അപ്ലൈ ചെയ്ത് കഴിഞ്ഞാൽ മാത്രമേ തിയറി കമ്പ്യൂട്ടേഷൻ കമ്പൈലേഴ്സ് എന്ന സബ്ജക്റ്റിനെ ആൻസർ ചെയ്യാൻ പറ്റുള്ളൂ. ബിക്കോസ് അക്കോർഡിംഗ് ടു the lot of questions can be framed from theory computation and compilers. Okay, the logic may be entirely different. Okay, but the procedure we will study, we will work a lot of questions from the gate and nest syllabus, and if you can do all the questions, I am guarantee that you can crack the the net examination. Okay, അപ്പോൾ അതുകൊണ്ട് അതിനെക്കുറിച്ചാണ് ഞാൻ ഈ ക്ലാസ്സിൽ നമ്മൾ മെയിനായിട്ട് സംസാരിക്കുന്നത്. ഓക്കെ, ആദ്യം ഞാൻ എടുക്കുന്ന ടോപ്പിക് എന്ന് പറഞ്ഞാൽ കമ്പൈലർ ആണ്. ബിക്കോസ് കമ്പൈലർ അറിഞ്ഞു കഴിഞ്ഞാൽ കുറെ ഫീച്ചേഴ്സ് കമ്പൈലറിന്റെ നമുക്ക് പറ്റും. ഓക്കെ, അപ്പൊ ഫസ്റ്റ് കമ്പൈലർ എന്ന് പറഞ്ഞ സബ്ജക്റ്റ് ആണ് നമുക്ക് സ്റ്റാർട്ട് ചെയ്യുന്നത്. ഇവിടെ പറഞ്ഞിരിക്കുന്ന ഈ കാണുന്ന സിലബസ് തിയറി കമ്പ്യൂട്ടേഷനിലെ റെഗുലർ ലാംഗ്വേജ് ആൻഡ് റെഗുലർ മോഡൽ, കോൺടെക്സ്റ്റ് ഫ്രീ ലാംഗ്വേജ്, ട്യൂറിംഗ് മെഷീൻ, ദെൻ അൺസോൾവ്ഡ് പ്രോബ്ലംസ്, കോംപ്ലക്സിറ്റി തിയറി എല്ലാം വരുന്നത് തിയറി കമ്പ്യൂട്ടേഷനിലാണ്. നമ്മുടെ മെയിൻ ആയിട്ട് കമ്പൈലർ ഡിസൈൻ സ്റ്റാർട്ട് ചെയ്യുന്നത് ഈ മൊഡ്യൂളിലോട്ടാണ്. സിന്റാക്സ് അനാലിസിസോട്ടാണ് കമ്പൈലർ ഡിസൈൻ സ്റ്റാർട്ട് ചെയ്യുന്നത്. സിന്റാക്സ്, the runtime system, intermediate code generator, code operator, etc. Okay, so these are the different syllabus. Again, there are some syllabus, computer network data communication also. So the corresponding staff will handle that session. I am mainly concentrating on compilers and theory of computation. Sometimes I will deal with the DBMS also, but now I am mostly concentrated on compiler design. Okay, so you are, I think I heard about your introduction. Most of you are from background of MCA and MSc. I think you might have studied the subject compiler design. Can you respond? What about do you study the compiler design? Yes, okay, somebody is telling yes. So you can unmute and you can talk. Okay, because this should be an interactive session, otherwise you will not get anything. Okay, so how many of you studied compiler design? Please tell me. How many? Okay, chat also. How many of you studied compiler design? So almost all studied compiler design. Yes, you studied. So the thing is that in the compiler design, what you might have studied is only theory. Okay, theory behind the compiler design. But in net examination and all, they will not about the theories. Okay, explain parsing algorithm, explain what is compiler. These type of questions they may not ask. Okay. ഇവിടെ നമ്മൾ മെയിനായി ചോദിക്കുന്നത് എങ്ങനെയാണ് കമ്പൈലറിന്റെ പല പല കൺസെപ്റ്റുകൾ നമ്മളെ അപ്ലൈ ചെയ്യാന്നുള്ളതാണ്. അപ്പൊ ഇതിന് ഒരു യൂണിവേഴ്സിറ്റി മോഡൽ സ്റ്റഡിയിൽ നമുക്ക് വിത്തിൻ ദ ടൈം ലിമിറ്റിൽ നമുക്ക് ക്രാക്ക് ചെയ്യാൻ ഭയങ്കര ബുദ്ധിമുട്ടാണ്. DOCയിലാണെങ്കിലും കമ്പൈലർ ഡിസൈനിലാണെങ്കിലും ഒരു പ്രോബ്ലം തന്നു കഴിഞ്ഞ് കഴിഞ്ഞാൽ നിങ്ങൾക്കത് കമ്പ്യൂട്ട് ചെയ്താൽ നിങ്ങൾക്ക് അതിന്റെ ആൻസർ കിട്ടാൻ വലിയ ബുദ്ധിമുട്ടുള്ള കുറച്ച് ടൈം പെർമിറ്റ് ചെയ്യാണ്. പക്ഷെ ഇവിടെ നെറ്റ് എക്സാമിന്റെ കേസിലും ഡേറ്റ് ആണെങ്കിലും ഏതിനായാലും ആ വിത്തിൻ ടൈം ലിമിറ്റ് വളരെ ഇമ്പോർട്ടന്റ് ആണ്. അപ്പൊ ആ ടൈം ലിമിറ്റ് അറിയണമെങ്കിൽ ഡിഫറെന്റ് ഷോർട്ട് കട്ട് മെത്തേഡ്സ് ഇൻ ഓർഡർ ടു ഡു ദ processing or computation. So you should be familiar with that type of shortcuts in order to crack the examination. Okay, so today I am just introducing what is compiler and some theory behind the compiler, and let us see some in detail about the compiler design in the next class onwards. Okay, because if you are today we will discuss about so you know everything about the compiler. So what is a compiler? Compiler, it is actually it is a system software. It is known as a system software. So there are two types of software. രണ്ട് തരത്തിലുള്ള സോഫ്റ്റ്വെയർ ആണ് ഉള്ളത്, ആപ്ലിക്കേഷൻ സോഫ്റ്റ്വെയറും ആൻഡ് സിസ്റ്റം സോഫ്റ്റ്വെയർ. And one more thing, keep a separate notebook for the compiler design. Okay, because if I am telling some important topic at that time, you can note it down, and we can if you are not okay, we will discuss again later. Okay, so you can note it down every point, and there are a lot of problems in the slides also. There are a lot of problems will come at that time. You need to work out. So keep a separate notebook for the compilers and keep it with you. Okay, then only we can study the subject. Okay, if any doubt, any clarification is needed, you can interrupt me. You can tell again. You can, sir, please explain me once again. Then we will discuss again. Okay, so compiler. So what is a compiler? I already told you. It is a system software. System software adum namakku ariyana karyam. There are two types of software which is known as a system software and application software. Is system software ennu parnal the software which is used to manipulate the system. And the application software, it means it is used to for different application. For example, banking application, IRCTC. These are examples of application software. But what is a system software? For example, the system software examples are OS. OS is one of the system software. Compiler, linker, loader, interpreter. These are also examples of system software. The software which is used to different types of softwares. This is generally known as a system software. And now we are studying one type of system software which is known as a compiler. Okay, so you might just know the definition of the compiler. So what do you know about the definition of the compiler? What do you know about compiler? You know the definition is that compiler is converting from high level language to a low level language. Okay, so what is input of the compiler? High level language. What is output of the compiler? Low level language. So high level language means it is used for the user. For example, C++. It is very easily can be manipulated by the user. Okay, but unfortunately system couldn't understand these type of high level language. System understand what? System understands only zeros and ones. So somehow you have to convert your high level language to a low level language. That means low level language which is it is a combination of zeros and ones. Okay, so that is actually the duty of compiler design. In order to convert high level language to low level language, we are using a system software. That software is known as a compiler. Okay, we have another software also like assembler, interpreter, etc. We will come to that later, but today we will focus on, in this class we are concentrating only on compilers. Okay, normally what is the input of the compiler? High level language. What is output of the compiler? Low level language. Okay, so input of the compiler is high level language. So what type of high level language you know? For example, different types of input files. For example, .c. If you are writing a C program, .c. So it is a .c extension is an example of a high level language. And .java, etc. That type of .txt, .doc. These type of things are examples of high level language. Okay. So what is a low level language? What is a machine level language? The extension of machine level language is a exe file, .exe. Okay, you know you might come across with the different exe files. So after execution you are producing an exe file. So what is the input of compiler? Input of compiler is high level language. That may be any extension .c, something like that. What is output of the compiler? Low level language. No, it's actually low level language, but you are always, I am asking you whether it is an exe file. Output of the compiler is an exe file. I already told you that output of the compiler is a low level language. The low level language means a combination of zeros and ones. Again, I already told you that low level language means it is an executable file. You know, yes, it is executable file. I am asking you, what is the output? What is the input of the compiler? High level language. What is the output of the compiler? If I am telling output of the compiler is .exe file, are you agree with or not? Anyone respond, please, because I can't see your chat box because I am under the screen. So anyone unmute and tell me. Are you agree with me? I am telling you input of compiler is any high level language extension, and output of compiler is .exe. Are you agree with that? No. Why? I already told you it is an executable file. Executable file, it is a low level language. Then why are you not aware that it is not exe file? So do you know about a file which is known as output?
Output exe file
Yes, stop. Output. Output exe file ആണോ ഇല്ലയോ എന്നാണ് ചോദിക്കുന്നത്. ഞാൻ പറയുന്നത് ഇപ്പോൾ exe file ആണെന്നാണ് പറയുന്നത്. Okay. ഞാൻ പറയുന്നത് it is not exe file. No, I am telling it is not exe file. അല്ല exe ഞാൻ പറയുന്നത് it is not exe file. Output of the compiler is not exe file. That is the main difference. Okay, output of the compiler is not exe file. Output of the compiler, it is known as a object file, .o file. Okay, so you might just study this one, computer science. Okay, so can you tell me the difference between .exe, .o file, exe file and object file? You might have heard about object file, isn't it? Yes, object file. Anyway, you will come across like object file. So anyone it is possible to explain what is the difference between object file and an exe file? So the thing is that I will explain the compiler design. You know, there are different phases of compiler design, like lexical, syntax, semantic, intermediate code generator, code optimizer, target coder, etc. And after these phases of compiler is producing a file which is known as an object file. And the object file, I am agree that it is a combination of zeros and one, but it is not executable. If you want to execute this object file, you need to take the help of another system software which is known as linkers and loaders. Okay, linkers and loaders. That I will explain what is the purpose of linkers and loaders. And after linking process, again I will explain what is linking process. After linking and loading process, only exe file it is created. Okay, so don't tell. Somebody is asking what is input of the compiler, you can say it is a high level language. What is output of the compiler, you can say it is a low level language. But you cannot say it is exe file. It is a object file. Okay, so output of the compiler is low level language and it is known as an object file. And after object file, we are doing some manipulation with the help of linkers and loader. And after linking and loading process only, we will get a executable file. Okay, that is the story. Okay, and again after 2 or more 3 classes, I will clearly give you the picture of object file. What are the different object file possible? What are the different exe file possible? How the object file is converted into a exe file with the help of linkers and loaders? What is the function of a linker? What is the function of a loader? And why the compiler is producing object file only? And what is the role of assembler, etc. We will come across in the course. And the thing is that each and every term it is important. Why? Because this itself can be frame a question in the examination. Whether it is an input of the compiler, what is output of the compiler, whether it is an object file or exe file. This type of manipulation is needed to crack the examination. Okay, don't worry about this one. We will come to. These are just rewinding something. They already I'm just rewinding something about the compiler, and we will go to the detailed part again later. Okay, and so my again one next question. So suppose you already familiar with the computer, and suppose I am going to write a C program. I am ready with the C program. Suppose if you are writing a C program, output of the C program, okay, it is an exe file, you can see the output. So what are the necessary steps in order to produce an exe file? If you are giving a some file to computer, that means if you are giving some file to computer, I am asking you what are the necessary steps in order to carry it out to produce a exe file. What are the necessary steps to produce an exe file? Can you explain, anyone? No, I will explain. So in order to produce an exe file, we will see the procedure. Okay. So you can see this is a C program, hello.c. So somebody will come across with what may be the next block, where it will go, whether it is directly go. Anyway, compiler is needed. In this process, you know compiler is needed. So what may be the next block it will go, where it will go, whether it will directly go to the, compiler. No, it will go to a block which is known as a preprocessor block. This is a block which is known as a preprocessor. So C program, whatever may be the program, it is not directly going to the compiler. It is going to a special block which is known as a preprocessor block. There are two duties assigned for the preprocessor block. First duty it is known as a file inclusion, and second duty it is known as a macro expansion. Please note it down. First duty it is known as a file inclusion, and second property it is known as a macro expansion. And what is a file inclusion? File inclusion means, suppose in your program you may come across with something like hash include some file name, or hash include stdio.h. And hash include user defined files header file include here. Okay, so all these header files should be included in the original program. So that is not the duty of the compiler design. So all the header file, all the user defined or library files should be included in your program, and that is not the duty of the compiler design. It is the duty of a block which is known as a preprocessor block in order to include all the object files. In order to include all the header files. Okay, that is the first duty. And another duty is known as a macro expansion. You know what is a macro. In C programming, you will come across with macro, something like hash define, etc. Okay, so if some macros are there, all the macros should be expanded before the compilation process. This is also not the duty of the compiler to expand all the macros. It is the duty of a preprocessor block in order to include all the macros. Okay, so there are two duties, file inclusion and macro expansion. Okay, so what is input? It is a high level language. Where it is going to a block which is known as a preprocessor block. Okay, so after preprocessor block, what will be the input? It is a high level language. After the preprocessor block, still it is a high level language, but it is known as a pure high level language. What is a pure high level language? The file which is free from macros and all the files are included, it is known as a pure high level language. And this pure high level language, it is giving to the block which is known as a compiler. Okay, and here we will study what is a compiler. In compiler, there are different phases that we will explain later. What are the different phases of the compiler? But you know what is a compiler. Input of the compiler is a pure high level language, and I already told you output of the compiler, it is an object file. But here you can see I am not giving an object file. It is giving to another block which is known as an assembly program, assembly level language, .s. Compiler output .o file, it is converted into an assembly program. This is for the older compilers. Okay, for the new machines and all, this is not the process. In new machines, new architecture, the process is that the compiler output is directly converted into object file. But in previous cases, some years before, the output of the compiler, it is going to an assembly program, and assembly level program, it is a .s file, and this .s file, it is going to a assembler. It is a like compiler only. It is converting assembly level language into a object file, and this is going to a object file. Now assembler is converted into a object file. But this is the earlier case. Now the case is different. Compiler is directly converted into object file, and in this object file, it is going to a block which is known as a linker. Object file, it is going to a block which is known as a linker. I already told you the duty of the linker is to link different types of object file. What is an object file and all we will come across in later next classes, and we will see different types of object files. These all object files to be linked, and this is come out a .out file. Okay, a .out machine executable file, and this is loaded into memory with the help of a loader, and this is loaded into memory. Okay, so exe file will produce after the linking operation and loading operation. It is loaded into memory when it becomes an executable file. This is the story behind the step in order to execute a program in a computer. That means there are a lot of system software associated with in order to run a program. It may be a compiler, it may be an assembler, linker, loader, OS. Who is loading? Actually, loader means this is an OS, operating system. That is loading your program. Different OS mechanism, different job scheduling, different CPU scheduling, according to the memory management technique, OS will load the memory, OS will load the program into different parts of the memory. So actually loader, it is an OS operating system. Okay, so these are the some of the system software which is involved in order to execute a program. You need a compiler, you need a preprocessor, you need a compiler, you need an assembler, you need a linker, you need a loader for this process. Okay, this is a story in order to execute a program, and this flow we will spend our most of the time in the design of a compiler. Nowadays, the compiler, I already told you, nowadays the compiler is converting high level language to a object file, not assembly file. In previous case it was assembly file, but now it is directly converted to an object file. Now we will see what is a compiler. Okay, so this is the story of the compiler design. This is known as a compiler phases. There are different types of compiler phases. First one, it is known as a input of the compiler. It is high level language. High level language, it is giving to a phase which is known as a lexic analyzer, and output of the lexic analyzer, it is known as a tokens. This is giving to the next block which is known as a syntax analyzer. Another name of syntax analyzer is parser. And this output of the syntax analyzer is a parse tree, and this parse tree it is giving to the next block which is known as a semantic analyzer. Still the output of the semantic analyzer is a parse tree. This parse tree is giving to the next block which is known as a intermediate code generator. Output of intermediate code is a 3 address code, and this is giving to the next block which is known as a code optimizer. And after code optimizer, it is going to a optimized code, it is giving to a target code generator, and this is actually it is converting into a, here it is, I am telling it is an assembly program, but it may be an object file. Okay, so it is object file. Nowadays it is object file after target code generator, and all these phases are communicating with two special module which is known as an error handler and symbol table. All this block, in order to implement all this block, he will take the advantage, or they will take the advantage of symbol table and error handler. Okay, so in this step we will study what is a lexical analyzer, what is lexical analyzer is doing, what is the role of the lexical analyzer, what is the input of the lexical analyzer. We will take some examples and we will implement lexical analyzer. After that we will go to the syntax analyzer like this. Okay, so in these phases, very important question. 75% of the questions is coming from the syntax analyzer. This is the main part of compiler design, syntax analyzer. The heart of the compiler design, it is generally known as a syntax analyzer, and this is considered one of the toughest block in the case of compiler design, syntax analyzer, because syntax analyzer is responsible for checking the syntactic errors. In order to check the syntactic errors, there are different methods. These methods are generally known as a parsing algorithm and parsers, etc. We will study later. Okay, we will study. If you know very well about syntax analyzer, the compiler design is over. The remaining parts are very simple. Okay, somewhat semantic analyzer also some problems are there, but most of the problems you can see it will come from the syntax analyzer, and some problems are seen from the semantic analyzer. All the other blocks deal with some theories only. Okay, so this is very important, syntax analyzer and semantic analyzer. And I am guarantee you that I am solving different gate problems and also net problems. If you can solve all the questions, I will give you all the questions, I will give you the solutions also, we will discuss in the class also. So if you can do all the questions, I am guarantee you that you can easily pass an net examination with the help of this compiler design. Okay, the thing is that while explaining the class, sometimes you may feel it is okay, I can do that one, but the thing is that for this subject a regular practice is needed in order to crack a new question. Because whatever may be the different types of questions I may given you, the question paper may be an entirely different question. That is the story of compiler design. Okay, we can discuss about the methods. Sometimes if you are really luck, you will get the same question, but the model may be same. Okay, this is approach. Approach may be same, but at the in front of the question paper, you have to frame a new answer. Okay, that's why you have a limited amount of time. You need to crack a new problem, but the method may be same, but regular practice is needed. I will giving you a lot of exercises, and that you need to do regularly in order to crack the examination. I am taking for the BTech students. Normally in BTech students also, the lot of the supplies are coming from the computer design and theory of computation. Okay, so but these are very important subjects. Okay, any competitive examination you can see a lot of questions. You may also feel about that. A lot of questions may come in the this one, compiler design and theory of computation. Okay, so again, I'm not going to the next slide because here also I can explain more. You can see, suppose I am asking a question. Okay, very simple question, very common sense question. Very simple question I am asking you. Anyone can answer. Suppose there are 1,000 machines. Okay, there are 1,000 machines. And assume that these all are of different architecture. That 1,000 machines and our machines are different architecture. Okay. So this machines like a program. Suppose a program on execute. Suppose I need to execute a C program in all these machines. Okay. So in order to execute this program, you must design a compiler design. You must design a compiler. Like a compiler, we design execute. So I am saying ഈ 1,000 മെഷീൻസ് ഉണ്ടെങ്കിൽ നിങ്ങൾ എത്ര കമ്പൈലർ ഇവിടെ ഡിസൈൻ ചെയ്യേണ്ടി വരും? 1,000 മെഷീൻസ് ഉണ്ടെങ്കിൽ എത്ര കമ്പൈലർ ഡിസൈൻ ചെയ്യും? ഓരോ മെഷീനും ഓരോ കമ്പൈലർ വേണ്ടി വരും. കാരണം ഒരേ ലാംഗ്വേജ് ആണ്, സെയിം ലാംഗ്വേജ് ആണ്, സെയിം ക്വസ്റ്റ്യൻ ആണ് ഞാൻ ഇംപ്ലിമെന്റ് ചെയ്യാൻ പോകുന്നത്. അപ്പോൾ ഞാൻ ചോദിക്കുന്നത് ഡിഫറെന്റ് ആർക്കിടെക്ചർ ആണ്, എത്ര കമ്പൈലർ? ബിക്കോസ് ദീസ് ആർ ഓൾ പ്രോഗ്രാമിംഗ്. ലൈക് കമ്പൈലർ എന്ന് പറഞ്ഞ ഒരു പ്രോഗ്രാം നമ്മൾ കോഡ് ചെയ്യുന്നതാണ്. നമ്മൾ സിസ്റ്റം ഡെവലപ്പർ കോഡ് ചെയ്യുന്നതാണ് കമ്പൈലർ ഡിസൈൻ. ബിക്കോസ് വി ആർ ഓൾവേസ് റെസ്പോൺസിബിൾ ഫോർ ദിസ് വൺ കോഡിങ്. ഞാൻ ചോദിക്കുന്നത് അങ്ങനെ ഒരാൾ കോഡ് ചെയ്യുകയാണെങ്കിൽ എത്ര 1,000 കമ്പ്യൂട്ടർ ഉണ്ടെങ്കിൽ എത്ര കമ്പൈലേഴ്സ് വേണ്ടി വരും? Please answer. Please unmute and talk, or you can type anything. You need to interact, otherwise I will not go to the next slide. You have to answer. You are concerned about this one. You can talk. How many compilers are needed? Etra compilers avashyamund execute cheyan. This should be an interactive session. If it is a classroom, I can ask you about this one. But if you want to make online class effective, you should interact. Otherwise, it may be a one-man show. I am telling you something, you are hearing. That may not be expected, because you can feel free about asking questions. Please tell, according to your view, you have to answer. Everyone has to answer. Then only I will go to the next block. Okay, somebody is telling don't know. Anyway, others please respond. Who discuss this one? Anusri is telling don't know. And what about the remaining people? Okay, Asha, Mary, Chako, what about your view? So the thing is that this is these are the phases of compiling. Okay, and I am telling you that lexical, syntax, semantic, intermediate code generator. Up to intermediate code generator, it is front end of the compiler. And last two phases, it is known as a back end of the compiler. Front end of the compiler and back end of the compiler. That is very important. Front end and back ends. Lexical, syntax, semantic, intermediate code. Up to intermediate code, it is known as a front end. And after, it is known as a back end. Which one is a back end? Code optimization, partial code generator. So why it is known as a front end and why last two it is known as a back end is that. So the thing is that whatever may be the machine, the number of machines, whatever may be the architecture, whatever may be the pipelining mechanism, whatever may be the whatever may be the hardware details, the first four phases is not dependent upon any architecture. Okay, it is independent of, it is independent phases. Okay, lexical, syntax, semantic, intermediate code. Up to intermediate code, the compiler is not depending upon any hardware. Okay, so it is completely completely machine independent. So if you want to design a compiler design for different architecture, that means 1,000 systems are needed. No need to implement different compiler for different machines. That means that first 4 phases is common for all. So you have to prepare only one common front end, and according to the architecture, according to the pipelining, according to the registers, according to the instruction set, you need to modify only the last 2 phases. Which are the 2 phases? Code optimizer and target code generator. That's why it is known as a back end of the compiler. So that is the beauty of the compiler. The thing is that it is very easy to code the first 4 phases, and according to the architecture, you can define it for different machines. That's why it is known as a front end, and that's why last 2 phases it is known as a back end of the compiler. Okay, so that is the story of the front end and back end. Now in next class onwards, we will discuss in detail what is a lexical analyzer, what is input, what is output, and how can you implement a lexical analyzer, what are the different problems it is solved, so it is come across with the NET examination or GATE examination, and we will see how a new problem can be approached in a lexical analyzer. After that, we will go to the real phase, which is known as a syntax analyzer. We will spend most of the time here. We need a lot of classes. I advise you to not miss any class in the syntax analyzer, because if you are missing some portion in intermediate for code optimizer, it is very easy to buy the textbooks or books are available, questions are available, you can crack. But syntax analyzer and semantic analyzer, try to attend maximum classes. Okay, so if you know that one, I guarantee that you can crack the examination. Okay.